In this video, I want to explain you the fundamental principles of the DC motor, how torque, the RPM, the voltage, current, how all these variables are related to each other. And instead of just showing the equations, I want to demonstrate it in practice. So here I have the DC motor connected to the power supply, and currently I have 2 volts. So let me finally connect the cables. So here, as expected, the motor started spinning. There's nothing much to say. But what I would do, I would just increase the voltage. So it was it's 2 volts currently. I will set 4 volts. And what's happening is that it started spinning faster. And from this observation, we can write our first equation. The armature voltage is proportional to the RPM, the rotation speed. So if we need faster rotation, we need to increase the voltage. Okay, this is our first observation. So let me set it back. The next thing to say is that the DC motor has windings inside, has a long copper cables, and because of that we have some internal resistance, and it's about all of the motors we work with. So from that we can write another equation, is that the voltage we provide, yes, is equal to the armature voltage that I just demonstrated plus current multiplied by R. So the resistance of the DC motor creates some voltage drop. And then when we don't have any load, when it's just a spinning without any load, I is really low. So we can assume that the input voltage is equal to the armature voltage. Next thing what I will do, I will put some load. How do I do it? I will create some friction. So let me remove it. And as you see, the motor started spinning slower. Okay, it started spinning slower, but at the same time we can see that the current has increased. Okay, and it's a direct consequence of the equation that I just showed you. When the current increases, what's happening is that the armature voltage decreases, and because of that the RPM drops. Okay, simple as it is. So when the current increases, the armature voltage decreases, or sometimes we call it back EMF. Back EMF decreases, and because of this we have the drop of the RPM, the rotation speed. Okay, from that we have the second equation. The third important equation is about the torque, is about torque and current relation. So when I just showed you right now, it's a 86 milliamps, the power consumption. So if I squeeze it, what's happening that the current increases. So the torque is proportional to the current. Okay, the torque is basically how much load the motor has. Okay, so right now there's a minimal load, that's why the current is also minimal, but once I set the load, it started increasing. Okay, so this is what I want to explain you. Next thing, we are going to drive the motor using a PWM signal.